Right, we're looking at lungs again, and they want us to look at the biological consequences of smoking on the lungs. So remember, we said you get cancer. There's chemicals in there called carcinogens. You have what is it? Coronary heart disease. Coronary heart disease. You've got bronchitis. You've got emphysema. So we need to talk about these. Yeah, I think that's it. Right, okay. Right, first of all, smoking causes cancer because of the carcinogens inside, because of the carcinogens in the cigarettes. Right, that's the first one. The next one, smoking the coronary arteries become blocked up with cholesterol. Coronary arteries become clogged up with cholesterol due to smoking, which can cause coronary heart disease. Coronary heart disease, leading to heart attacks. Right, what's the next one? Bronchitis. Smoking damages ciliated cells, the cilia. Let me see, there's something here. There you go, we can discuss that down there. Smoking damages ciliated cells, which stops mucus clearing, mucus being cleared from airways. This causes inflammation of bronchi, and the disease is called leading to bronchitis. Right, the last thing you can say is emphysema. Right, the alveoli are damaged, So surface area, surface area of alveoli decreases, so less oxygen diffuses in for aerobic respiration. This is called, let's say, this is emphysema. So what you have, let's go over that. So you've got a few things going on here for 5 marks. So smoking causes cancer because of the carcinogens. The coronary arteries become blocked up with cholesterol, which can cause coronary heart disease. Right. Wait a minute. This bit we didn't need to include because it's talking about the lungs. But it's all there for smoking, but it's related to lungs, so we should focus it on the lungs. Smoking damages the ciliated cells, which stops the mucus being cleared from the airways. This causes inflammation of the bronchi, leading to the disease called bronchitis. The alveoli are damaged, so the surface area decreases. Right, so there's less oxygen for aerobic respiration. This is called emphysema. So you can't exercise as much. And one more, smoking also contains tar, which builds up in the lungs. Yeah, which again reduces the transfer of oxygen. Right, I think that should do the blocks. Okay, let's move on. Right, again, this is the same thing. It's to do with the lungs. So what did we say? Carcinogens cause cancer. So I'm just summarizing it because we've just done it. Bronchitis is due to the ciliated cells being damaged. So that builds up the mucus causing the bacteria build up. It causes infection of the bronchioles and the bronchus. You have emphysema, and what does that do? That damages the alveoli. So there's less. So look, I'm using, this is a shortcut for me, less surface area. So that means that there's less efficient diffusion of oxygen in and CO2 out. Because remember, we need to get carbon dioxide out of the blood through the lungs. You've also got buildup of tar, which blocks the lungs, making diffusion less efficient. So diffusion is less efficient because there's less surface area to work off. Efficient. That's it. It's exactly the same as that other one. So that was from a different year, question 7. This is from a different year, question 4. Okay, right. If a pregnant woman smokes cigarettes, this will increase the risk of her producing a smaller baby because they contain carbon monoxide. So just carbon monoxide increase the risk of producing a smaller baby. So look, carbon monoxide is C with 1 carbon. Carbon dioxide is C with 2 oxygen. They're both poisonous, but this is really poisonous. Why is that? Because so in your red blood cell, you have a little molecule called hemoglobin. What happens is oxygen comes along, binds to that, and together happily they float away, providing oxygen to all your cells. Now, when carbon dioxide or carbon monoxide come, carbon monoxide is stronger than oxygen. It kicks oxygen out, and then it goes with the hemoglobin. But the carbon monoxide is no good for your cells for respiration, for aerobic respiration. So you end up with, right, let me write this here, carboxy hemoglobin. And that's no good for your cells for aerobic respiration. So that's what we need to say here. So what happens is, where are we? Right, how do you get a smaller baby? So what happens is the carbon monoxide attaches to the hemoglobin. So there is less oxygen for aerobic respiration. So less energy. So when you have aerobic respiration, you release energy for the cells to do whatever they need to do. So there's less energy for growth of cells or the baby, in effect. Right, okay, that should do it. Right, okay, here we are. Right, you've got 2 types of cell. Let's try it like this. You've got these little hair-like structures, little hair, and they move that way and that way. So if you've got, so this is a ciliated I always spell that wrong. It's a single L, ciliated cell, and this is a goblet cell. This produces mucus, that sticky stuff. So when a bacteria comes in, It's flying in. What will happen is it'll get stuck here. Now, that needs to be cleared, otherwise the goblet cell will produce more mucus and it'll just create more, it'll just block up the airways. So what happens is these little hair-like structures, they move around backwards and forwards and they start pushing this back out. It goes to your throat and then you clear it just when you clear your throat. Now, people that have got damaged ciliated cells or bronchitis, like smokers, they end up having to, after you hear them coughing from deep down, it's like smoker's cough because it doesn't bring it up to the throat. Otherwise, this causes this pathogen can cause infection, or if it's a dust particle, it can cause irritation and inflammation. But right, so that's how that works. So this is the lining of the bronchioles. So you've got the bronchus. So you've got the trachea. Then you've got the bronchus, and then they split up into bronchioles, and they contain these ciliated cells. So saying small hairs on the surface of the ciliated cell are called cilia. The goblet cells produce mucus. The mucus is moved by the cilia. Suggest how ciliated cells and goblet cells protect. So that's how we've just described it. So the goblet cells produce mucus to trap. Goblet cells produce mucus to trap the pathogen or bacteria or dust. Bacteria. And the ciliated cells remove the mucus containing the bacteria. Remove the mucus out of the body. So that's how they work together. Right. Chemicals in cigarette smokes reduce the movement of cilia. So that's why people who smoke often have to cough up. Yeah, because the cilia are damaged and can't move the mucus out. So you have to cough it out. So it has to be coughed out. Right, okay. Paramecium. Right, okay, this is more reading off graphs and answering questions. So you've got a single-celled organism called Paramecium, and these little hair are called cilia. So what somebody did was they carried out an experiment. They put in different brands of cigarette into a solution for 20 minutes, and then they checked what was the movement of the paramecium with the different brands. So you've got a brand A, brand B, and nothing. This is the control. This lets you know whether the test that you're carrying out is actually affecting it. So that's your control. So if you look here, There's more movement in brand A than brand B, but there's most movement under control. So it looks like as if brand A cigarette has an impact, it's reduced it by this much roughly. And brand B has reduced it by this much. And you also notice that the difference, brand B reduces movement, more movement than brand A. So we've got, the questions will be based around that. So what they're saying, describe the effects of the solutions on the movement of the cilia. So both brands reduce movement of cilia. Brand A, okay, let's talk from the other point of view. Brand B reduces the movement more than brand A. Okay, what should the scientists use as a control? Just water, rather than anything else. Right. The scientists concluding that smoking reduces movement. Another science suggests this may not be a valid conclusion. Why this may not be a valid conclusion? Right. Okay. So, where are we? They've used an organism. Oh my word. They've used an organism, Paramecium. That's not a human being. You've only used. Right. It's not said that he's. They've not repeated it. So let's start writing this. Human lungs are different to single-celled organisms or to the Paramecium. The human lung might react totally different. It doesn't say that he has not repeated the experiment to make sure that it was valid. They've not mentioned, so they've not repeated the experiment. They've not explained or controlled the variables. For example, light, temperature. They've only used or tested 2 brands. What was it? Yeah, so they're not humans, they're different. Whilst this was in humans smoke cigarettes, and here, whilst here, they have used a solution. They have used a solution. That'll make a difference to how effective it is. Yeah, so there's a lot here. So human lungs are different to Paramecium, 2 different organisms. It's not been repeated. You've not controlled other variables like light, temperature, pH, etc. Only used 2 brands. You could have tested more brands, and humans smoke cigarettes as opposed to put them in a solution. Although with vaping, it could be different. Right, let's move on to this question. How many more questions? Loads of questions. Right, okay, we might have to do this question and then take a break. Okay, let's have a quick look at this. You've got trachea, bronchus, bronchioles, bronchioles, these little things are called alveoli, and this is a diaphragm. Diaphragm. It helps me remember the spelling. Diaphragm. Okay. P is bronchioles. Q, trachea. R is bronchus. Right. Structure S is the diaphragm. Diaphragm. When you breathe out. So when you've breathed in, the diaphragm is flat. When you breathe out, the diaphragm muscles relax and it becomes more dome-shaped. So the diaphragm muscles relax and the diaphragm done it again, becomes dome-shaped. It moves up. What effect does that have? That decreases the volume in the thorax and increases the pressure. So then what happens is air moves from, we don't want to talk about the intercostal muscles and the ribs because it's talking about the diaphragm. Air moves from high pressure inside the lungs to outside low pressure. Right, we can check that. Okay, that's fine. So the diaphragm muscles relax and the diaphragm becomes more dome-shaped. It moves up. This decreases the volume and increases the pressure. So the air moves from high pressure inside to low pressure outside. That'll cover it. Right. So you've got this person on this peak flow meter. And this is what you do. Suggest the unit used to measure peak flow. So it'll be in volumes, what? It'll be centimeter cubed. Explain why step 2. Right. If you set the meter to 0, make sure your fingers are not touching and the meter is horizontal. Right, because the reading will not be accurate if not set to 0. So you're going to end up either under reading it or over reading it. What else would happen is if the finger is obstructing, if this finger is blocking the air, you will end up with a lower reading. And gravity will affect the meter, because there's this, can you see that slider there? That slider there, if it's not horizontal and tilting upwards, it will take more effort to move the slider from there to there, and on the opposite side, if it's there, the slider will move more, it will give a false reading. So you have to keep it horizontal so it moves the right amount to give an accurate reading. Gravity will affect the meter. Gravity will affect the meter and give a false reading. Okay, I think that should do it. Right, we'll do this on the next video.